My microphone volume was a little low in the last few, so I apologize for that. I think I tweaked it. Hopefully it's not way too loud. I used a limiter and a noise reducer so you couldn't hear people walking above me, and that have the gain. So I cranked the gain back up, so you're probably going to hear some ambient noise that you didn't before, but you'll be able to hear me a little bit better, hopefully. Okay. When we left off, we were looking at some things, and I did add three circles here, and we forgot a device. So let's just review on that. One of the assignments before was to go through and rebuild this mess in a little bit more organized fashion. So we've got no addressing at all in the physical layer. At the data link layer, we have the MAC address, which is the physical address, called the physical address because it doesn't change. Layer 3, the network layer, we have the IP address, which is the logical address because it could be different every time you fire up. Normally it isn't, and in a DHCP normal, and that we haven't talked about DHCP yet, but we will a bunch later. In a enterprise situation, or even at home, you really don't want your IP address changing that much. And we could do a static address, but that's a pain to do. And we'll find out when we get a little bit in this class, and especially when we get into TCP/IP class, that all of the, well, I guess in server class too, we talk about it in TCP/IP, but we actually set it up and push things in server, where we set up a DHCP server and then we pass options. So a lot of the configuration options that we need for clients, instead of touching 1,500 clients manually, we can just change the options in DHCP, and when it pulls a new address, the next time the machine fires up or it times out or renews, then it'll pull those settings. So it's a whole lot easier. Anyway, usually it's fairly stable, but it can change. And then we get up to the transport layer, port 4. Layer 4, we have port numbers. So we go MAC and IP and port. And IP and port, we saw in NetStat, are usually the IP address and a colon and the port number, but the MAC address is usually talked about separately. These two are tied together, but the MAC address is usually not in there. Now, on the devices side, I totally forgot. We talked about repeaters and multi-port repeaters, which are hubs, and bridges and multi-port bridges that are switches. And then at layer 3, we have routers. And then we also have a multi-port router. And in class, I would ask, what do you call a multi-port router? And the answer is a very expensive router. So it's still a router, even if it's multi-port. Typically, your routers are going to have an inside interface and an outside interface, and that's it. And oh, hey, this brings up a sensitive topic, but let's talk about it. One of my pet peeves is when someone mentions a wireless router. Now, I know, and I'm not blissfully unaware of the situation, but technically speaking, routing happens at layer 3, wireless happens at layer 1 and 2, and so you cannot wirelessly route because wireless does not actually act at layer 3. Wireless is a cable substitution, so for us, technically, we would put wireless at layer 1 because it uses MAC addresses to link back and forth, and because of the way the packets go, there are elements of layer 1 and 2, but essentially it's a layer 1 replacement. We are using wireless instead of a physical cabled setup. It does not work at layer 3. So the notion of a wireless router is actually incorrect. Now, what it actually is a device that has 3 components. There'll be typically it's ELO. There'll be a single yellow port, which is a WAN port. This is the router. So that is the uplink to the internet. Okay, and it works at layer 3. And then typically you will have 4 blue ports, and those will say LAN, and that is the switch. So you have a 4-port switch and a 1-port router uplink, and then you have the Wi-Fi, which we're going to call 1, but you could argue it's 1 and 2. And so your connectivity could be hardwire cabled through here, or it could be through Wi-Fi. So let's say 1/2. I guess you could technically say this is 1 and 2 as well. So what's happening is these are communicating, and when you connect via Wi-Fi, you connect here, and then this actually connects across to layer 3 in the router, and it goes out to the internet. But you are not wirelessly routing. You are wirelessly communicating with the device that is then routing that information at layer 3 out. And usually this is, well, let's say this is your ISP's device. So whatever this WAN connection happens to be, you're talking IP addresses at the ISP, and it's translating through from there. But this really isn't, this is not a wireless router. The issue comes that this is actually a 4-port switch with a router or a WAN uplink and a Wi-Fi with Wi-Fi capability. So 4-port switch with a router uplink and Wi-Fi capability makes for a terrible box title if you're gonna set up a device that's going to be sold. So Wi-Fi router, I understand from a marketing standpoint, sounds much better, but it is totally inaccurate. So if we're talking at some point and you really want to get my goat, say that you're going to go install a Wi-Fi router, and I will berate you because you should know better. But I mean, I get it. That's what they're called, but it's really inaccurate. Same thing in client class when we talk about printers versus print devices. Technically, they're print devices. Paper comes out of a print device. The printer is actually the software running on the PC. So if you don't understand, I was talking on the phone with somebody trying to help him yesterday, and they were apologizing that it was actually a Wi-Fi configuration issue, and they mentioned a couple times that everything on the box, and they tried to read the instructions, and it all seemed like a different language, and I get that, and if you're at that level of technical complexity, I'm going to let it pass. I'm not gonna make fun of you or belittle you, but once you've had this class and you mention a wireless router, I'm gonna come after you. Okay, so I forgot a couple things, and wanted to make sure that we reinforce those things. There actually is a lot going on this page, and if I just took a screenshot of this and said, "Hey, here's the notes for the day," that is a horrific, confusing mess. So, I mean, your homework is supposed to be to go through and kind of digest this and figure out what it is and why it's there and how it interrelates. Reading chapter 2 in the version 6 book is going to do a lot to actually help out, I think, because you go through and you read it, and then you can point to... Now, do I think this is good to do for a test or for the certification? Not really, but for on a certification exam, you're going to give me a piece of paper. We talked briefly about doing brain dumps. A part of my brain dump is going to be a really short version of this. So it's going to be the 7 layers, and then I'm going to put some things. If there's anything in here that I'm possibly confused about, that I think I'm going to put in the wrong place, I'm going to dump those ahead of time, so I have this kind of framework of things. If I know that the 3-way handshake is at layer 4 and I'm never going to confuse that, then I'll leave that completely out. Routers, bridges, switches, repeaters, and hubs, sometimes people will do that just because when we're talking about the device, you need to know what layer it's running at, because you need to know what it can see and what it can talk to and what it can interact with. So that's kind of up to every individual person. but you do need to understand this and be able to put all these things in the right place. Okay, beat that horse to death. I think we went through the rest of it. I'm not sure that we actually went through the rest of the notes here. Yeah, actually, I think we did. For the 802 categories, 802.2, 802.3, 802.5, and 802.11, we went through that in the book. Those are the ones. 802.2 less so. 802.3, 5, and 11 far and away, and 3 and 11 really, realistically, the ones you're going to interact with are going to be 802.3, which we also know as Ethernet or contention communication or CSMACD. We'll basically use all those words interchangeably, and then 802.11 is wireless. Said we'll do a little bit of wireless in here, and then we have the entire wireless class that we'll talk about things. All right, the next section we're going to talk about is cabling. Let me get OSI out of the way. Oh, and I had forgotten to post the OSI notes. I apologize for that. When I'm in the heat of battle recording something, I can't record and post, and I thought I had. And anyway, so this next section, we're going to start at layer 1. We're going to start working our way up in the stack. So we're going to talk about cabling, and I've got some photos that are of different cable types. I've got 4 or 5 buckets of cable samples. So if we were in the classroom, I'd be pulling out cable samples, passing them around. You'd actually be able to look at them. You're going to have to settle for Google Images for now. Oh, hey, totally different subject, but let me, not to one-up myself, and I probably shouldn't tell you this until afterwards, but whoop, if I could spell. All right, I'm going to introduce you to Professor Messer, who does kind of what I'm doing, but he does it much better. Although I will say I have 4 monitors. He only has 2. Well, I guess he's got a laptop there. He's got 3. So he's got what he can see a preview on the screen and what's going on. But so the 2 different monitors there. Essentially, he's doing the same thing. I think he does a better job, but in my defense, I haven't been doing this that long, at least online. I think I do a pretty good job in the classroom. So I have just gone Professor Messer and then clicked on the Net Plus. And then if you scan down, he actually he's broken them up much better than I have. We actually are going to watch him for the fiber section. So that'll be at the end of this cabling section. And I normally would do that in the classroom because I don't have examples of all the fiber. And there's a difference between handing it and passing it around class and actually getting to see. So when we do optical fiber, and especially optical fiber connectors, I would just show that in class, especially, and we'll do that here too. So you don't have to check this out because we'll actually use it, and you can see what he does. So it's kind of what I'm doing, but it's kind of distilled down, packed into things. This, I think I do a pretty good job of covering everything in detail and fitting things together. But these really are excellent reviews. So if you were getting ready for the Net Plus, you're getting ready for the final. And I recommend students to go through and plow through here so that, and most of these videos are less than, almost all of them are less than 10 minutes. There are a couple longer ones, but most of them are less than 10 minutes, and you can cruise through, and they're pretty detailed and pretty calculated. He's done probably 5 or 6 versions of these. So, and his pictures are good. His support stuff is good. Anyway, we'll use it. Just wanted to bring that up. All right, back to the notes. If I can find them. There we go. All right. So 3 major cable types: coax, fiber, and twisted pair. In reality, the 2 that you will bump into, the one you'll bump into the most is going to be twisted pair, and unshielded twisted pair far and away is going to be what you're going to deal with. And whoops, don't do that. And then fiber is going to be the next one. And fiber, you're not going to have on small business installs. home installations, you're not going to have fiber really. The only time you're going to have that is if you're in enterprise, and hopefully none of you will see coax, although it's going to be on the test, so it's going to be on the certification, it's going to be on the test. I'm kind of surprised that it hasn't been reduced more, but it's still there. And this has been true since the very beginning. If you have two different items and one is used 95% of the time and one is used 5% of the time, in a testing situation, it's usually 70-30, something like that. So the older technologies, even though they're older, not used very much, still have an outsized impact on the tests, which is kind of weird, unusual. But from a testing standpoint, I will say, and I can kind of see behind the curtain, I have to make the test up scenario, leaving older technology questions in, especially when they reinforce, because these are going to have maximum cable lengths, which is a big thing. They're going to have connectors on them, which is less of a big thing, but maximum cable lengths really is the biggest thing here, and being able to differentiate cable types, and you got some acronyms, so there's some value in playing that against what we have in our unshielded twisted pair. But still, anyway, I've had students complain before, and I've thought the same thing. This is really outdated. Why are we still covering this? And just learn it, know it. At some point, and it's been funny over the years, I had one student who was pretty ugly, complaining it was in server class that we were doing all kinds of really old stuff and we hadn't got to the new stuff, and we were going to. We just, you got to start with the basics and you got to work your way up. So we had done a bunch of the old stuff, and he was, what are we going to get to the stuff that really matters? And I said, well, this really matters. You gotta build the foundation before you can build a house on it. And then after he graduated, he ended up actually taking care of machines that were the old. This was when NT4 was still. We were in 2000. Using Windows 2000 and maybe 2003, and I was still covering NT4 and the configuration and whatnot. And he ended up actually taking care of some NT4 machines. So he said that was pretty ironic that he complained about it, but that was the thing he ended up doing. So you never know, especially in industry, especially in factories, industrial settings. You're going to get, I've still got one machine. Well, I guess I've upgraded it now, but it was a couple years ago. It was still an NT4 machine, just NT4, running on a gigantic plotter. Why did they still have it? Because it still worked, and they were going to use it until it didn't work, and I got called in because it didn't work. And, that's 1994, and that was probably 2016, maybe 2014, 2016 that I worked on that. So that's a really, really good long run for a box that had been running basically 24/7, supporting a plotter. It ended up it lost a hard drive, and because I'm a hoarder of sorts, I had parts to fix it. So yay. One of the things about this pandemic is I'm going through all my stuff and throwing a bunch of stuff away. So it's been painful, but I've made 2 trips to metal salvage, and reminds me I still have a bunch of hard drives I have to dismantle. A bunch of massive 4 gigabyte IDE hard drives that I need to take apart. Okay, let's get through this. So 3 types. I have to mention one of the midterm questions. Which of the following are cable types? Choose all that apply. Coax, fiber, twisted pair, wireless. Typically about a quarter to a third of the class chooses wireless as a cable type. So the absence of a cable typically is not a cable type. Just FYI. So coax, and there are actually two kinds of coax, and we can see here we got thin net and thick net. So as far as categories go, there are really four different types: thin net, and we're going to do thick net first. Thick net, then thin net, and then coax. Then fiber and twisted pair. So these two are synonymous. So it's thin net coax and thick net coax. If you and I will do this. If I said what are the three cable types, and you said thin net, thick net, and twisted pair, thin net and thick net are both coax, so you would get 1 point for coax, and then you get 1 point for twisted pair. So just make sure that you know that coax is actually broken down into these two subcategories. All right, I'm going to start with thick net first. Thick net is thick. It's pretty heavy duty. It's called frozen yellow garden hose for a reason. So it's pretty bulky, and it was originally designed for bus networks to be a major trunk line. So if you had, go back to document camera, if you had an office building with a hallway down the middle and a bunch of offices on either side, so this would be the trunk line that would run from one side to the other, or from one area to another. A lot of times it would be a trunk between sections, but in this case we could have, especially if we had vampire taps, and I'll show you that in a second, we'd actually have taps that would hook on, and then we'd have thin net connections actually coming off into the different offices. So this, I actually have this Cabletron system Ethernet transceiver, so the Ethernet 802.3 transceiver unit. It's actually a multi-station access unit, MAU. This actually, that may not be the same MAU. That MAU would be token ring. Anyway, this piece of cable comes through, and this vampire tap is what it's called. Actually connects. It has teeth that bite down onto it. Now you can have this, so if it was terminated, it would screw in on one side and come out the other side, but this actually shows you the vampire tap. So this has screws on the other side, and it actually has teeth that bite into it, so when you screw down into it, you don't have to cut the cable, you just clamp this in. And if you've ever put in 12-volt outdoor lighting, landscape lighting, it comes with a cable, and then usually you take the lights and you snap them over. There's a vampire tap, you snap them over the cable, and when you hook them together, it actually bites in, and that's how it picks up. It's got one tooth that goes in the power and the ground. In this case, it just bites into the middle. Anyway, and this is an AUI connector, attachment unit interface. I'm not going to ask you that. That used to be a really popular, this AUI. I think I've got another picture somewhere. Yeah, there you go. So that's the AUI connector. It is a parallel connector that allows a connection to come out, and yeah, it would go toward the network card. So it takes this serial communication and breaks it out from the transceiver. Again, this is that AUI. I've been pointing to this screen this entire time. I'm so sorry. I'm looking at the screen, and normally you're looking at the screen, but you've been looking at that. So I am so sorry. Let me back up. So frozen yellow garden hose, vampire tap, and AUI. So this is the land view connector. There's the AUI connector. You're screaming at the screen. We can't see what you're talking about. All right. So there's it says thick net cable going through, and the vampire tap there, and the AUI coming out to the device. I said AUI we're not using these for bus. We're not using them for token ring. So this would have been I mean, when I came to Lakeland in '98, this was still used, but on its way out. By the time we got to 2000, 2003, something like that, most of these devices were gone. Again, sorry about that you couldn't see. But Vampire Tap, AUI. Don't need to know AUI. You do need to know, however, that this says right here Ethernet 802.3 transceiver unit. And that becomes important because Ethernet and IEEE, so it's using those interchangeably there. And transceiver is a transmitter receiver, so it actually is able to convert between, in this case, it's converting between serial and parallel. It could be converting between all kinds of things. And this is an RG8 radio government for RG, and that will be important. We'll need to know that. That'll be in the notes. If I can find the notes. There we go. All right. So thicknet, and there's the RG, the 58 and thinnet. So 1/2 inch thick, fairly difficult to bend, pretty expensive. We do have a maximum cable length of 500 meters, and we said we use them for trunk lines, and we have Vampire Taps and transceivers and AUIs, and totally ignore that page. I don't even know what version. That's probably like version 3 of the book. I just haven't taken that out. There we go. All right. Because it is standard Ethernet, it was 10 megabit. And when we go to the IEEE naming scheme, remember that the Institute of Electrical and Electronics Engineers sets up the standardization for naming and specifications for cabling. But they have, well, their standard is the base throughput, which in this case is 10 megabit because it's standard Ethernet. This one is baseband or broadband. And we have to sidebar and talk about that for a second. All right, so baseband, I think early on we talked about plumbing. I think we may have talked about baseband a little bit already, but plumbing in your house is baseband. Our plumbing example is baseband. If I pour grape Kool-Aid into a pipe and it flows out to all the other stations on my network, what's going to come out of that pipe is going to be the same thing I put in. It's going to be grape Kool-Aid. We can't have, you turn the faucet one way and you get one thing, and you turn the faucet the other way and you get something else. You can't, there's no tuner. So anything with a tuner would be broadband, and anything that does not have a tuner is baseband. So everything, all LAN communication. Actually, let's clarify that. All wired LAN communication is baseband. So everything that we're going to do is going to be base. The only thing that would be a broadband would be your DSL or cable modem, because it actually has multiple communications that are actually at different frequencies and can be filtered out. Wi-Fi, you could argue, is broadband, although that's, yeah, by definition it would be. It's closer to that than it is baseband. On that particular channel, it runs as baseband, but anyway. And then this last, we had base throughput, and then broadband or baseband, and then length in 100-meter increments. So this is 500 meters. So this would be 10 base 5. Okay. And if we go back to its IEEE name, is indeed 10 base 5. So that's how we come up with that. It says it comes in PVC and plenum grade, and we're going to get to that. I think we'll get to that. Well, actually, so I don't forget, we'll talk about it. PVC and plenum are the two descriptions of the coverings. So Let's do Cat5 PVC. Now look at that. What's the difference between PVC and plenum cabling? So, cost. When we're talking to somebody like, what's the difference? I don't know, about $100 a box. So PVC is the standard stuff that you're going to get. The $50 to $75 a box for 1,000 foot of unshielded twisted pair is going to be PVC by default. And it can be used in everything, but if you're ever in a fire, if it ever burns, that outside PVC casing will smoke, and it will produce potentially harmful, noxious fumes. So they make plenum cable, and plenum cable plenum means air handling space. Yes. So plenum cable is what you would run if you were running something in a drop ceiling and you were actually pulling usable air through that airspace, through that plenum, that airspace. If you were pulling usable air and pumping it into the room where the occupants of the room would breathe it, you're by code supposed to have plenum cabling in there, or you're supposed to have it in conduit so it won't melt or smoke or whatever else. If you're going to put it in the wall, PVC is fine. The only time you'd have to do it is when the cable was in a common airspace, so that if there was a fire in that ceiling and the fumes came off of it, you wouldn't want anyone breathing those. So let's see. And I didn't check this at a time. Is required for use if you run your cable in air handling spaces. If you're running them between floors, it's fire resistant. It won't melt. It also emits less toxic fumes when it does burn. And typically it's just way more expensive. So yeah. And you're only going to buy plenum cable if you absolutely have to. In fact, I think I've only had one box of plenum cable ever. Because usually you're going to be in a ceiling and there's going to be ductwork. So the ductwork's going to go through the ceiling and it's going to come to a vent in the drop ceiling. Then you don't have to worry about it. And the floor, it's even less, unless for some reason you're in a server room and you're pumping air through the floor. Now, we did have that in our data center. We had all of the air was actually pumped into the raised floor space and then came up into the room. And I would absolutely bet you just a phenomenal amount of money that every bit of cable that we had on that floor was not plenum grade. But they didn't have a fire, so we didn't have any issues. Okay, so that's thick net. And the one thing we're missing out on is I have a 25 or 50 foot roll of plenum cable, and I get it. It's heavy enough. We call it frozen yellow garden hose. It's heavy enough that I get it to like behave like a snake, like a cobra, and I can usually get it to actually just lock in place because it's pretty thick and doesn't bend very well. All right, so thin net looks surprisingly like just your coax cable. If you ever had cable TV, it looks like that. This is RG58 and coax cable is RG59, so it's basically the same thing, except instead of an F connector on the end, it actually usually has a B and C connector. Okay, there it is. All right, so this is a RG58 radio government 58. BNC actually has several different. British Naval connector is the most popular. Bayonet Navy, and then British Neil Councilman are the three different. And I don't know that I have. I don't have our book open. But the chapter. Hang on. Let me get the book. Okay, I'm back. I got the book. So in the 6th edition, chapter 3 is transmission basics, and there's a lot of things that we'll come back to in this first section. And I just locked it up. That's awesome. There we go. So there's coax cable. There's our F connector that I just talked about that we normally would see on thin net. There's a B and C connector. So it actually has a locking. Now, my background, originally I was going to be a video guy, and video connectors use BNC connectors for in a professional studio. I worked in a TV studio. So when the connector actually that you're hooking to has posts on it, and they slide in these slots right here, and then it goes down, and then you twist lock and the thing goes in, and the wire will come out of the connector before that connector comes out of the device. So it's a really strong positive connection. Now you could have BNCs on thicknet, but usually you would see them on thinnet, and somewhere I had the other connector, and you can see them here. So they go on, and if we had, what I really would like to see is, let's see if we can get a network. There we go. All right, so a network card that has a BNC connector right there. You see the post. There's post facing down to, and you lock onto it. Now, if you see this is an ISA card, and if you see this, you know that's going to be, well, I guess it could be bus or it could be token ring. And this actually has an RJ45 as well. So probably is a bus, because you would have, typically we would have that on both. Yeah, it doesn't say what it is, but yeah, wow, these are RJ45 BNC. Oh, there's a PCI. Ooh, $30. No one is gonna. As I said, I was just going through during the pandemic and throwing a bunch of stuff away, and I chucked an entire box at one point, not just recently, but I think I had one of those still that I put in recycling, because we'll never need that ever again, hopefully. Okay, oh, look. So there's a piece of some thinnet. This would probably be thinnet. Look at layers, yay. Oh, look, wireless LAN. All these are in layer 2. Let's see if we get down to that picture. There we go. So our coax cable, they've hyphenated it there. That's pretty funny. So we've got a network card with BNC. This is a T connector, and then this is probably thinnet. This could be a bus network, probably is, but it may actually be, yeah, okay. So I'll give it away at 10^2. Yeah, this is probably set up on a bus, but if you came from this end around, they would have to have token ring cards instead of Ethernet cards. So it depends on the kinds of cards that are actually hooked to it. We could actually use both, which made it confusing, because you might have RJ45s and it might be a bus network as opposed to Star Ethernet, and you could have BNC connectors on both as well. Today, if you see anything that's not Star Ethernet, it's super old, probably not going to be used. Okay, so again, RG58, it looks surprisingly like the coax cable that you would have for cable TV. You can bend it pretty easily. It has a maximum cable length of 185 meters. Now, the maximum cable length ends up being pretty important, and so we had 500 meters before for thicknet. Thinnet has 185 meters. Early on, you're going to need to know everything in meters. Eventually, you're going to have to know things in meters and feet. So 1 meter equals 3.28 feet, or a little more than 3. So, if you're doing, and one of the tricks you'll see, and I'll do that to you too, so that you get used to it. On the Net Plus, they'll have blah, 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 thicknet, and you're thinking 500, and so what's the maximum cable length of thicknet? And they have 500 feet. And you're just thinking 500, and you shoot for 500 feet. I think it's 1609 feet and what you can really do is you take this times 3 and you add a little bit. And usually it's not going to be, you know, it's going to be 500 feet. It's going to be 1609. It's going to be 37,500 or something. So, I mean, it's not even going to be close. So if you can estimate times 3, this times 3 is about 600. And, you know, adding a little bit, you're right around 600. So it's going to be right around 600 feet and right around 1600 feet. And usually you can use a standard calculator. I believe in the Net Plus you can still use an embedded standard calculator. So you actually, if you knew the 3.28, you actually could do the multiplication. I wouldn't say that it's worthwhile memorizing. I memorized everything in meters all the way through. Oh, and regular Cat 5, Cat 6 is 100 meters. And that is 328 feet, which means, you know, becomes really easy to remember that when 100 meters and 3 years. So really, I remember that, and then I remember these, and then I have to calculate anything, then I go from there. I think that's the easiest way to do it. It takes the least amount of brain space for me. Okay, so 185 meters. Used actually to the desktop, so thicknet would be used in the hallway or on the trunk lines, and then the short runs would actually be thinnet. Said we had ends in a BNC or British Naval connector, and if we go here, there's British Naval connector, and I think in the chapter summary at the end, if I really quickly flip through here, Bayonet Neil Councilman, British Naval connector, Bayonet Navy, you'll see sometimes too. I'll take any of them, but British Naval tends to be the one that gets used the most. So that's the one if you're going to remember one, I would prefer you use that one. And it's standard Ethernet, so Ethernet base was 10 megabit, then we had fast Ethernet at 100, and then we had gigabit Ethernet and 10 gig Ethernet from there. So we go back to our dock camera. Our spin here. Our IEEE name, because it was a 10 megabit, it's baseband because everything we have is base. And this last one was in 100 meter increments. How many 100 meter increments we had? It's 185 meters, and so they round up to 10 base 2. So don't be confused by that's 200 meters. It's still 185 meters, but they've rounded because they want to do 10 base 1.85. So we were looking at that other sheet online that talked about 10 base 2. So 10 base 2 and 10 base 5. 10 base 2 is 185. That gets to be something you just have to remember. All right. So again, hopefully you won't see thinnet. Now, it would not surprise me if one of my grads who just recently graduated goes out to work in a factory and they find some machine that's hooked up to a server that's not hooked to the internet, and we've got some thinnet that actually connects it. And why would it still be there? Just because most of these industrial machines are going to run until they don't. Like this plotter that I worked on, and the plotter still worked. Actually, they had enough problems with it. If they were buying another replacement one, that was like a 10-year or 15-year-old plotter to replace the 30-year-old plotter that they had. And at the time, it was a really expensive device, and they spent a lot of money on it. So, as long as it does everything we need it to do, why do we need to replace it? So, and I just got called in because nobody else knew how to work on equipment that was that old. So that was amazing. All right, so there's coax. And I'm going to skip fiber. We're going to go to twisted pair. We'll come back and we'll pick up fiber. You're going to see twisted pair in UTP and STP. If I can go back to here, I've got, close these out. Close. Okay, so there's some unshielded twisted pair. 24 American wire gauge. We'll do American wire gauge later. Category 5. This is actually technically it's 5E. 5 has been around for a long time, but 5 will not support gigabit speeds. 5E will support gigabit speeds, and then we have Cat 6, and I really haven't seen any Cat 7, so we really have 5E and 6 that we're using now. 5E you'll see at Menards and Home Depot. It's pretty easy. I'm still installing. I mean, I ran a custom line into my office at home for all of this, and I run a Cat 5. I actually have gigabit switches in the house, but I do have a network attached storage, a NAS. I mean, the Cat 5 will push gigabit, so why do I need Cat 6? It's more expensive, it's harder to terminate, the connectors are more expensive. Now, the difference between Category 6, and we'll talk about this later, I'm jumping way ahead, but Category 6 has a tighter twist, it has a higher quality, and the connector in Cat 5 can actually connect way down here in the way it connects, but the end of the twist to the termination has I forget how many millimeters it has, but it's pretty generous. In Cat 6, I think you only get a couple millimeters between the end of where the twist is and the actual termination. So the connectors for Cat 6 actually look a lot different, and they're more expensive. Usually they're through connectors. Let's see. Cat 6. Let's do Cat 6 connector. All right. So you can see here in this picture, this is going to be different than what I'm going to show you. We're actually going to watch some videos, and I may just do a termination just to show you, but these wires actually pull all the way through. And the point of this is I've got, let me click on that. So the point of it is I've got a twist that comes right down to here. So I've actually taken the wires and I pulled them through and pushed this connector as high as I possibly can, and actually pushed the connectors right into the twist. And then when you connect it, then you cut it off and we're as high as possible. Oh, by the way, I had somebody, normally we would terminate cable. We would create a straight through and a crossover cable in class. But you don't actually you don't strip the ends of the individual wires, because these actually have like a vampire tap, so they actually have teeth there. You can see from the sides. As I'm moving, it's making you nauseous, I'm sure. But here we go. Click there. So you can actually see this one has 3. Usually they have 2, but they have these little teeth that when you push this down, when you actually terminate it, these actually pierce the outside jacket and they make contact with the copper on the inside. That's actually how it's done. But every now and again I'll have someone who will try to strip the individual wires and put them in. So it is pretty easy, but these are more expensive. As Cat 6 pass through, do they have Cat 5? No, they don't have. All right. So the Cat 5 ones, at one point long ago, Big Lots had a 10-pack for $1. So they have been pretty cheap. And let's see, we're on Amazon. So if I do Cat 5E RJ45 connector, I should get 100. We want 5E. There's a 100-pack for $9. Oh, hey, while we're here, I want to show you this. Look at it. Hey, I purchased this one 2 times. So this, look at this, $18. Actually, it's more expensive now. It used to be, I think when I bought it, it was $13.50 at one point. So this actually, when I was teaching, we looked up and somebody said, is that good? I don't know. So I bought them. The connectors are pretty good. The crimper is, if I'm out in the field and I'm terminating cable, this is decent. It is more difficult than the really nice crimper that I have, but it does the job. If you know how to terminate cable, you can successfully terminate cable just fine with that. This tester, I bought this tester for, I know, less than $10, and I think closer to $5. I think in the lab I have 3 or 4 of these exact, well, not branded that way, but I mean, they look exactly the same. They have different brands on them, purchased from different places, but they must all come from the same factory. This is the one I have in my cabling kit when I do consulting and I build cable. This is the tester that I use. We have 3 of them in the classroom. They're cheap, they're reliable. This, the right-hand side of that actually disconnects. And so I can, it's, you know, the one that says remote, I can put it on the other side of a cable. So if I have a really long cable or one that stretches out of the room or in a ceiling and drops down somewhere else, I can put that. You plug one side in, the remote end, and you plug the other side in, and then the lights and they'll actually go on both sides. So they'll, both of the number 1s will light up, and then both the number 2s. And if you're missing something, it just skips. Or if you got them out of order, it'll show you that they're out of order. So I mean, pretty inexpensive. And for the whole kit to get, I don't use the strippers very much. Usually I'll just use the strippers that are right here in the handle. But the tester and the crimper, you do this in a box of cable, and you can, yeah, I mean, you can do a bunch of cables for, let's see if they have a box. Can I buy a box of cable? Yeah, there we go. 1,000 foot of 5E. Actually, I have this Vivo here. Oh, no, the 1,000 foot box. I have a cabinet just outside of my office that has all of my supplies in it. I have a box of that. So $41 for 1,000 feet. And then you add another 17. So for $60, I can make 1,000 foot of cable. I can make 50 because you got 100 connectors. I can potentially make 50 different cables. That's pretty good. There was a point when copper was really expensive and these boxes were $100 to $120. So they've come down quite a bit. The one thing this does not have is boots, and I use boots on all of mine. They're actually strain relief, so the little, I want to point to the screen there, but you won't be able to see that. Wait, can I? Nope, I have to point this way. So the point, this is it. Tried to so the little curved thing on the top is actually where the clip goes, and it just prevents if you're pulling the cable backwards, it prevents the clip from getting caught and torn off. They're not that expensive. There's 100 of those for $7. So you know, we were at 60, now we're less. Now with tax, we're less than $80. And people don't have an idea of how much this costs. So if I needed 1,000 foot box of cable, people are going to think it's way over $100 anyway. And so, you know, I'm going to do a much better, much more professional job if all of my cables actually look like that. And I also like the fact that I can tag them with different colors. So I'll put different boot colors on for different things so that when you're plugging it in, like all the cable is going to be gray probably, but I can have different boots that are going to tell me that it's from one wall. Like both of the connections coming from one outlet can be one color, and then they can be a different color, so I can actually tell them apart. So that part is nice. And this pack comes with, does it come with 5 different? Oh no, it comes with a whole bunch of different colors. Yeah, so I mean, I have an embarrassing number because I do a lot of consulting, and so, you know, for $7, if I'm going to do a big wiring job, I may have to terminate. Trying to think, the biggest job I did is probably 30 or 40 cables. You know, yeah, I'll buy 2 packs just to make sure I have enough, and then, you know, I'm gonna bill out whatever, so it's gonna cover my cost. So having them, you know, it's a lot cheaper than buying cables that are pre-made. I mean, people about die when even you want a 20 foot or a 60 foot Cat 5e cable. Well, actually, they're not that much. But you can't have it like I need a 62 foot. You can't do that. Cat 5e cable. Let's do 50 foot. Now these will be pre-made, so it actually is going to be better. And there's a pre-made one at $10. So 50 feet, I can do 20 of those. So that would be $200 for 20 of those. Now it's a factory made, so the quality is going to be a little bit higher, and but I can put the boots on and I can make it look pretty much like that. So if it's going to be, you're going to have $200 for that. You didn't really need 50, you needed 36 or 42 feet. I can make you custom made 42-foot ones that are exactly the length that you need, and I can do it for, $80. So depend, if you're going to put in a whole lot, it does get, and if you go to Staples or Walmart, we used to go to Staples and it would be a 20-footer would be like $48. It's just ridiculous. So I mean, buying on Amazon, it's a lot more less expensive than it was buying it in. If you buy anything in the store, you buy a Cat 5 cable in the store. Oh, let's look. So there's a 50-foot. Oh, actually, that's not bad. $8.99. Okay, made me a liar. I was expecting it to be outrageous. Usually the cables will be pretty outrageous. Oh, one other thing, if you go to Menards or Home Depot, 1,000-foot box, let's say the 1,000-foot box, let's just go $41. It's not going to be $41. It's going to be way more than that. With this gigantic microphone, I can't see around it. Okay, so you probably saw it. Yeah. Okay, so that's not bad. 3 in stock and matte tunes. 1,000-foot is 60. Do you notice anything here? 24 5E indoor outdoor data cable. Okay, so that's indoor outdoor. I was gonna say that it got more expensive. There's Plenum. See, so 59, almost 3 times as expensive. But typically what will happen is, for this exact same thing, we got 1,000-foot is $60, 500 feet is going to be $50, 200 feet is going to be $40, 100 feet is going to be $35. If you're going to buy it, buy a 1,000-foot box, and you'll have it for however long you need it. Usually, if I'm doing a new job, I'll usually have a few older boxes, and sometimes when I'm pulling cable, it's nice to have, I've got white, gray, and blue, and I'll pull different colored cables, so I know if I'm pulling 2 from the same box, I can pull a gray and a blue, and then when I'm wiring in, this one's the blue and this one's the gray one, that makes it really nice. When I wired the classroom, I did the same thing. I bought 4 different colors, and so when I was pulling the cable bundles, I knew, you could tell when you were hooking on one end up versus the other, what the cables were. Otherwise, everything looks the same and you have to test it to be able to figure out. But usually if I'm going to do a big job or even a medium job, I'm probably going to buy a whole new box just because it's easier. So I think when I was cleaning out, I had 4 partial boxes, and 2 of them had maybe 100 feet or less in that I just took out and put in a Ziploc bag. And I've got them in a tub now. But yeah, it's easy to... because you're going to bill out $100 for a box no matter what it is, probably as your cost. You get that plus the ends plus the boots, and then your labor is going to cover all that. So usually it's not a big deal. Wow, we are almost an hour, and I am like 4 lines down. Okay, so shielded versus unshielded. That is unshielded twisted pair. This is shielded twisted pair. So this actually, many of the shielded pairs actually have shields on this individual pair, and then basically has an aluminum foil wrap on the whole thing. Some of them will also have a braid. The braid will take any electromagnetic interference or outside interference, and we'll take that in and take it to ground. So that braid is normally hooked to ground, so it takes any magnetic interactions and actually drains them off and protects the cable themselves. The individual wraps actually protect the individual pairs from having crosstalk. So, okay, we're partially through twisted pair, and just because we're at an hour, I'm going to stop, and then I'll pick it up and we'll finish up twisted pair in the next video. So I'll see you in a bit.